everyone, and welcome back to R&M LAB GH. Today, we are continuing the Pandora 0.1 project. As I mentioned before, this is a long-term project, and I want to share every step of this experience with you. Since it is a very substantial and detailed build, I have decided to split it into several episodes. This way, anyone who wants to replicate it can take their time and gather all the necessary materials. In today's video, we will focus heavily on the mechanical part to bring Pandora's head to life. We will build the mechanisms for the movements, which will later be controlled by two mini servo motors. In a project like this, mechanics are crucial to achieving smooth and precise movements. I want to clarify something very important that I haven't fully explained in previous videos. As you can see, I use all kinds of materials, often scrap, recycled parts, or low-cost materials that are easy to find. This is a deliberate choice. Even though using recycled materials requires a lot of extra study and work behind every component, I chose this strategy for one simple reason. I want anyone to be able to replicate my projects without needing expensive or sophisticated equipment. I could have built Pandora using 3D printing, aluminum, or PVC, but then, not everyone would be able to recreate it at home. This is the true heart of my lab, using simple materials and treating them to make them strong, waterproof, and durable. Behind what you see are hours of design to achieve an optimal and functional result with just a few euros. I hope this video inspires you to experiment, not just for the project itself, but to understand how important it is to combine mechanics with electronics and programming. With the right knowledge, even the simplest materials can produce incredible and precise results. Now, I will leave you to the mechanical build. I will check back in during the video to give you more technical tips and explanations. Enjoy the watch. As you have seen so far, I have removed the electronics from Pandora's head to create the bracket that supports the entire mechanical section, which is the foundation of this project. Today, we will be using the following materials: hot glue, super glue, and a plastic pipe clamp, the can used in plumbing to fix pipes to walls. We will also need a bearing with an 8mm inner diameter and a 20mm outer diameter, and a piece of Rilsan tubing. This is a standard tubing used in track air systems. It is very easy to find, inexpensive, strong and lightweight. We will also use some paper clips, small nails, wooden popsicle sticks, skewers, a 5mm bolt and nut, and a piece of iron wire that I salvaged from a clothes hanger. Finally, we will use some pressed cardboard. The Rilsan tube will serve as the head support. I am mounting the bearing onto the tube to ensure the left to right movement is very smooth. I will heat the pipe clamp to shape it into a bracket for the bearing and the head. As you can see in the video, I am attaching two pieces of iron wire to the sides of the clamp. These will act as supports and will allow the head to move up and down while also holding the entire structure together. Now, let's use the wooden sticks to create the support. We will use 4 of them, 2 for the right side and 2 for the left. We will glue them together using super glue, which will make the part very strong. Since super glue is cyanoacrylate, it blends with the wood fibers, turning them into a material similar to hard plastic, waterproof and easy to work with using tools. As you can see in the video, I can even drill through it without anything breaking or splitting. We will then fix these 2 wooden supports onto a piece of pressed cardboard, again using super glue. We will achieve the same result as with the sticks. The wood and cardboard fibers will fuse with the glue, creating a single, solid structure, just like a solid piece of plastic. The chemical reaction between cyanoacrylate glue and natural fibers is truly fantastic. It allows us to create brackets or any other structure in a simple way, while being incredibly strong at the same time. most complicated part of this structure is achieving all four movements effectively without making the mechanism too complex. This is important not only to save space but, above all, to keep the weight down. A complex structure requires more material and adds unnecessary weight, which we want to avoid. After a lot of design work, I came up with a solution that is simple to build, though it wasn't easy to figure out. I am using the Rilsan tube. Since it is attached to the head, it allows for left and right rotation. I will connect the servo directly to the bottom of the tube using its original plastic horn. I'll heat it to shape it into a mount for the tube, then drill 2 holes and use a small nail as a locking pin. This makes the connection solid but still easy to disassemble for repairs or upgrades. However, we face another challenge. If the servo isn't secured, it can't move the head, but if we fix it too rigidly, we get the side-to-side motion but lose the up and down movement. I solved this in a very simple way. The servo passes through the bracket we made with the sticks, but the gap is too wide. So, I added wooden spacers to the sides of the servo to create a sliding track. As you can see in the video, the horizontal servo is now held in place, yet it remains free to pivot on the vertical axis. This gives a smooth movement across all 4 axes. The head is now fully articulated and can rotate even while moving up or down. As you can see in the video, we will use the left side of the structure to mount the second servo, the one that provides the tilting or up and down motion. To connect it, I will use a simple paper clip. I am shaping it carefully to create the linkage which will be attached to the plastic clamp that holds the bearing. This system ensures a very smooth vertical movement. With this setup, we have finally achieved the result I was looking for: 4 axes of movement, all free and independent. Pandora's head can now move naturally in every direction. Now, all that's left is to secure all the parts permanently. As you can see in the video, during the final assembly, I am making the last adjustments and improvements to ensure the perfect alignment of all components. I am trimming any protruding pieces to prevent them from rubbing against each other. The goal is to have smooth, well-balanced motion so as not to strain the servos. This stage requires some patience to achieve absolute precision and synchronization of all moving parts. The bearing is secured with super glue and a 5mm bolt on the back, locking it firmly in place. At the top of the Rilsan tube, I am using a nail to lock the tube onto the bearing, preventing it from sliding downwards. This system is essential because it allows the structure to be disassembled at any time for maintenance or modifications, since the entire weight of the head is supported by the tube itself. The mechanical part is finished, and I am very happy with the result. Even though I used very simple materials, the build is truly precise and robust. Now, let's move on to the electronics to control the servo motors and the external power supply section. Arduino cannot handle both the OLED displays and the servos at the same time, so an external power source is necessary. For this, we will use a DC to DC converter to get a steady 5 volts for the servos since we are using a battery pack of about 8 volts. This voltage is too high for the servo motors and could damage them. This way, we will have 2 separate power lines, 8 volts for the Arduino and 5 volts from the converter for the servos. I will also use 2 male header strips to create a connector, making everything easy to disconnect. I will use the 5 volts and ground from the converter for the servos and pins 9 and 10 of the Arduino to control the movements. You can find the wiring diagram on the screen right now and also in the video description. That is all for today's video, as it was starting to get very long. I hope that, so far, you have found it interesting and helpful, especially regarding the mechanics and the use of simple materials. These methods can spark ideas for new projects or even for various types of repairs. All it takes is a bit of imagination. The next part of this video will be out soon. I can already tell you that we will be making further modifications to make Pandora as autonomous as possible. I also have other surprises in store. If you are interested in this project, I look forward to seeing you in the next episode. For now, thank you for watching. Please leave a comment and let me know what you think, what I can improve, or if you have new ideas for this project, I am ready to listen and bring your suggestions to life. Subscribe to the channel to help me grow and to allow me to bring you even better and higher quality content. Turn on the notification bell so you don't miss the upcoming videos, and leave a like. Thank you again, and I will see you in the next video. Bye.